WizitUp.
Another important topic we are going to look at will be chemical combination or bonding between atoms. Now, chemical combination or bonding involves the joining together of atoms to form molecules or compounds. Interatomic bonds are forces of attraction between atoms, and they include ionic, covalent, and coordinate bonds. Now, you have to understand that bonding occurs or joining together of atoms occur because the atoms want to attain the duplet or the octet electron structure of the noble gases. What I'm trying to say is that the essence, the reason why atoms indulge in bonding, or where one atom or atoms combine with other atoms, is to ensure that they attain an electronic configuration similar to that of the noble gases. In other words, they want to attain a stable electronic configuration. They want to attain a stable electronic configuration or a stable electronic structure. All right. Now, the interatomic bonding, from what you said here, interatomic bonds, they are forces of attraction between atoms, and from what we said, they include ionic, covalent, and coordinate bonds. First, what are ionic bonds? Ionic bonds. Ionic bonds. Now, when we talk about ionic bonding, we are talking about the transfer of electrons from a metallic atom to a non-metallic atom to form an ionic compound. I repeat, an ionic bond or ionic bonding involves the transfer of electrons from a metallic atom to a non-metallic atom. A non-metallic atom to now form an ionic compound or an ionic, to form an ionic compound or to form ions. Good examples occur with sodium and chlorine. Now, sodium is metallic, is a metallic element, while chlorine atom is a non-metallic element. Now, we notice that the metallic elements have mobile electrons, few mobile electrons, although they have a sea of electrons. But these mobile electrons can easily be donated to the non-metallic elements. So let's look at formation of some compounds. One, formation of sodium chloride. Formation of sodium chloride. In this arrangement, we notice that the sodium atom with an atomic number of 11, chlorine atom with an atomic number of 17, it is possible for the sodium atom with the following electronic configuration to lose the valence electron or the outermost electron to chlorine atom with electronic configuration of 287, having 7 electrons in the outermost shell. Now, we can see an illustration on the board involving ionic bonding. We have sodium atom and we have sodium ion. We have chlorine atom and we have chloride ion. Now, what gave rise to those ions, those structures on the on your screen will be explained in this way. First, for the sodium atom, we have 2 electrons we have 8 electrons, 2 electrons, 8 electrons, and 1 electron. So we're going to use what you call the dot and cross diagram. Dot and cross diagram in our bonding. Dot and cross diagram. Now, this represents the electronic diagram of sodium atom. Sodium before bonding. Electron configuration is 281. Now, for the chlorine atom before bonding, we have two electrons here. Eight electrons in the inner, in the middle shell, and 7 electrons in the valence shell, with electronic configuration of 287. So now, it is not possible for sodium to gain electrons from chlorine atom, since chlorine has 7 valence electrons, while sodium has only a single valence electron or 1 electron in the outermost shell. So the sodium atom donates this electron to the chlorine atom. By so doing, we're going to now have a new electronic diagram. In that case, sodium atom has to lose this valence shell. It has lost 1 electron, so the new structure will be what is illustrated in your screen here. This is the electronic structure of the sodium ion, and you will see that it has lost the outermost shell. So the new electronic diagram will be this: 2 electrons and 8 electrons. So that makes it to attain the octet, that is 8 electronic structure of the noble gases, argon and neon. All right. Now, in the case of chlorine atom and chloride ion, the chlorine atom now forms a chloride ion by accepting 1 electron from the sodium atom. And in that case, it has 8 electrons around it. 1, 2. This electron is gained from the sodium atom. So it is 1, 2, 3, 4, 5, 6, 7, 8. So, in other words, both the sodium ion and the chloride ion that are formed will attain the octet electronic structure of the noble gases. So they are more stabilized. They now have a completely filled outer electron shell, or a completely filled outer orbit. All right. So that is an example of an ionic bonding. Now, the next takes us to properties of ionic compound. But before then, other compounds that are formed by ionic bonding are calcium and oxygen. Calcium and oxygen. Now, in this example, the calcium atom has an electronic configuration of 2, 8, and 2. That's an atomic number of 20. While the oxygen atom has an electronic configuration of 2, 6. So what it simply means is that for the calcium ion, the electronic diagram would be all right, 2 electrons here, 8 electrons, and 2 electrons. Okay. Now for the oxygen atom, I have 6 electrons. Right. So now since calcium has 2 valence electrons, it can donate these 2 electrons to oxygen atom, oxygen and calcium. So now, at the end of the day, we're going to get a new bond, a new ions being formed. That means the calcium ion will now form a new ion. The calcium atom forms a new ion, that's calcium ion, which now has the electron configuration or electron diagram. Okay, and now it has 8 electrons because it has lost the outermost electron shell. This is calcium ion with electronic configuration 288. So it is stabilized. In other words, it has completely filled outermost shell, unlike at the initial stage where it has 2 valence electrons. Now let's look at the new oxide ion. We have 2 electrons. And we have this, right? So we have 2 extra electrons from calcium ion, and that also gives the oxide ion an electronic configuration of 2 and 8. So you can see that we now have 8 electrons in the outermost electron shell. So many other examples abound. For example, calcium chloride is formed. In this case, the calcium, 1 atom of calcium will require 2 chlorine atoms, so that each of the chlorine atoms will accept a single electron. Okay? 1 electron from 1 calcium atom and the other electron from the same calcium atom, so that they will complete the 2 chlorine atoms. Anyway, that's just by the way. So this is what we refer to as ionic bonding. Ionic bonding.
WizitUp